Hey everyone, we're going to continue with 2.4. This is page 34, right? Yeah, 34. We just finished 33. So you know at this point how to calculate a standard deviation. Now let's do some interpreting. A standard deviation, just so we know, measures a typical amount an entry deviates from the mean. Same units as the data set. So in other words, it's how spread out the data is. Okay. So a large standard deviation is going to have more spread. Large standard deviation, more spread. All the data values are equal. There's no spread at all. The standard deviation is 0. That makes sense, right? No spread, no standard deviation. And then if you have a small standard deviation, of course, you're going to have a smaller number. So here's a few examples, right, where we have all of these have a mean of 5. But they have different standard deviations. This first one has a standard deviation of 0, and that's because all the data values are 5. There's no spread. No spread, no standard deviation. Boom. How about this one, when you have a standard deviation of about 1.2? Yeah, we got some spread here, right? We have some data values that are right at the mean, and then we have some that are 1 away from the mean. And then we have some that are 2 away from the mean. So if we do some averaging of all that, this turns out to be about an average of 1.2 from the mean. Okay. Here's one that has even more spread. There's no data values at 5. We have some that are 7, which is 2 away from the mean, and some are 3 away from the mean. Over here we've got some 2s, and we've got some 3s, but more 3s. Okay, so that one turns out the average is about 3. Now that's not a perfect average because it's a standard deviation, it's a type of average. And especially when you're talking about sample standard deviation, we have that n-1 thing that throws it off a little bit. So the calculation turns out to be about 3, but the interpretation is still average is pretty close to 3 away from the mean. Okay, so let's practice with this. Try to just guess a standard deviation for each of these. Let's see. Let me use red on this one. This one has a standard deviation of what? So what would sigma be for this one? Using my population standard deviation notation. Sigma. All right, again, notice all the values are 4. And the population mean is 4. So there's no spread, so we would call that a standard deviation of 0. In the next one, we have still a mean of 4, but we have some 3s and we have some 5s. But 3s and 5s are all away from the mean of 4 by 1, right? So the mean is 4. We have some values that are away from the 1 above, some values that are away by 1 below. So averaging out all of this, the average spread seems reasonable just to say 1. This third one, the mean is 4 still. Now we have some 3s, which are 1 away, and some 7s and 1s, which are 3 away. So we have some values that are 1 away from the mean, some values that are 3 away from the mean. So if we're thinking about an average distance from the mean, averaging the 3s and the 1s would be about 2. So again, average distance from the mean is how we're interpreting standard deviation. The final thing is called the empirical rule. The empirical rule is only good for bell-shaped symmetric distributions, which turns out a lot of real-world data follows that distribution. So if you have a bell-shaped symmetric distribution, there's some properties that relate to standard deviation, and they're listed here in the bullet points. So about 68% of the data lie within 1 standard deviation of the mean. That's these blue segments here, right? So the mean is always in the middle. If you add the standard deviation, you get this line. If you subtract the standard deviation, you get that line. And the data values, how many there are, is a total of 68%. Even more specifically, 34% on each side of the mean. The second rule is the 95% rule. That's 2 standard deviations. So that goes to the next line here and there. That total distance is 95, and breaking it down into the segments, 35.5, 34, 34, 35, 13.5, sorry. All of that would add up to 95%, and that's if you add 2 standard deviations, you get that line. Subtract 2 standard deviations, you get that line. And then the final rule is the 99.7%. That's 3 standard deviations. That's all the way to the very ends, right? If you add up all of those percentages, you would get 99.7. And then anything outside of 3 standard deviations are just these 2 little percentages here, right? 0.15 above and 0.15 below 3 standard deviations. So very few data values will be outside of 3 standard deviations in a bell-shaped curve, specifically 0.3%, half below, half above. So let's put this to use in an example, number 6 here. In a survey conducted, the sample mean height is 64, so I can even write that down. X bar is 64, and sample standard deviation 2.7. And let's answer these questions about what percentage of women in the US are in these range of heights. A good way to tackle this is to create your own bell-shaped distribution, labeling the x-axis with the specific values given here. And that's what I've done below in advance to save some time. But notice here in the middle, I have 64. Right? So right here is 64. And then, yeah, that's what I meant to do. Right there, 64. And then if I add 1 standard deviation, add 2.7, I get 66.7. Add 2.7 again, I get 69.4. Add 2.7 again, 72.1. That's 3 standard deviations added. Right? So the other way, if I start at 64, subtract 2.7 once, I get that. Subtract it again, so subtracting 2.7 twice, I get that. Subtracting 2.7 3 times, I get that. Okay? So that's all set up pretty nicely. Now, if I have between 61.3 and 66.7, what percentage would that be? So if I were to draw that, that would be 61.3 is here, 66.7 is there. It's this segment here. What percentage is that? Notice those are 1 standard deviation from the mean. If I look back at my general chart, that's these guys right here, right? That's the 68% rule, or 34% plus 34%. So this one, the end result would be 68%. Okay, how about B? So between 58.6 and 69.4. So 58.6 is here, 69.4 is here, right? Notice, okay, we're talking about that. Those are each 2 standard deviations away from the mean. If I go back to my general, that's all the way here, right? Those. Now the general rule, I could just say, oh, that's 95. If I'm not sure, I have these percentages, I could just add them all up. 13.5 plus 34 plus 34 plus 13.5. I'll get the 95%. And that's the final answer. How about between 64 and 69.4? Okay. Let's try that. So where it's 69.4 is here, and 64 is here. Right, so we're talking about this segment. Right. So if you're talking about the slivers, there's these 2 sections like that, right? So look back up here, and maybe we can erase some of this clutter here. Right, but what I'm referring to now is these 2, right? And that's going to be 34 plus 13.5. So I can work that out. 34% plus 13.5% equals 47.5%. Okay. How about less than 58.6 inches? Let's try that one. Okay, so 58.6 is here, and it's less than. It's all these segments that are to the left of that one. And notice that one is the 2 standard deviations away. All right, so if I match that up with the general graph where the percentages are, right, let's get rid of all my clutter. It's all of this down below, right? 2 standard deviations below that, right? And so there's 2 percentages to add up, the 2.35 and the 0.15. So for that one, I'll go 2.35 plus 0.15, that's 2.5%, and I'm good. So hopefully that makes some sense. Okay, we have one more, which is more than 72.1. Okay, so the more than 72.1, uh-oh, didn't want to remove the whole thing. There we go. Will be way to the right over there, this little sliver, right? And then how many standard deviations? That's the 1, 2, 3. So it's to the right of 3 standard deviations. Okay, so 1, 2, 3. It's really just this little sliver in here, right? Which is that percentage right there, and that's it. So that would be a 0.15%. One additional question that might be asked, instead of what percentage of women whose heights are, what if you had 500 women, how many of them would you expect to be more than 72 inches, right? So if 500 women, how many above 72.1? Kind of a little additional question here. Right, I think that pops up in my lab. So then you just have to calculate the number, right? You would just multiply the 500 times the 0.15, right? And then calculate that out. Let's see, 500 times 0.15. Oh, but and then sorry, I can then convert that to a got to convert that to a decimal before I multiply. So actually, that would be move the decimal 2 places, 0.015. Right. Sneaky. Okay, so 500 times 0.0015 is 0.75, right, which is about 1. So 1 woman. So very rare to have somebody that's more than 72.15 inches tall. Out of 500, you'd expect 1, because that percentage is so low. Okay, that's the end of 2.4. Hope you enjoyed it. And in the next video, we'll finish off Chapter 2. All right, have a good one. Thanks. Bye.